Hello and welcome to the Daily Space for today, November 1st, 2019. I am your host, Dr. Pamela Gay, and today Annie Wilson and I are trading off as we work to bring you not just the news, but also a departure of what is currently a garbage scow from the International Space Station. Quite literally, they are taking one of the capsules that previously brought them a bunch of cargo. They have filled it with garbage, and now they're going to throw it out, and they're going to throw it off. So today's news is going to be a bit of a quick run through, but we can get it done. Don't worry. Now, one of the things I want to point out is right here, we have a new donation goal. And when I say donation goal, I literally mean donation goal. If you scroll down on Twitch, one of our panels is our Streamlabs donate panel. And if you donate through Streamlabs, it's really easy for you to get a tax deduction here in the United States as laws allow. And right now, what we're trying to do is raise funds to pay for our servers all of next year. This year, the OSIRIS-REx mission has been paying for our servers, for which we are so very, very happy. Next year, we have no more rocks to count, which means we also have no more funding for our servers, unless I get a grant. And we do have grants pending, but consider giving, please. If everyone that typically watches this show gave $30, which I know is a lot, but over the course of the year, aren't we worth $30? That would allow us to cover all of our bills. Okay, that's all I'm going to say about that. I am now going to switch to talking about the science of the day. And today's first story is one that looks at the question of just how habitable are all these habitable planets that keep getting discussed in the news. In the past decade, we have gone from thinking that planets primarily exist around stars like our sun to knowing that if you're a star, you probably have a planet. Now, since the majority of the stars out there are red dwarf stars, this means the majority of the planets out there are around these red dwarfs. And red dwarf stars live for billions of years. And while we know that they're terrible when they're young, throwing off huge flares and magnetic storms, there's been a lot of hope that maybe if these worlds survive that process and somehow are able to rebuild the water on their worlds, maybe life could evolve later, maybe. Well, in new research, astronomers have looked to see what about the magnetic fields of these systems after those terrible twos are over. This is work that comes to us from Rice University and is newly published in the Astronomical Journal. And what has happened here is researchers led by Alison Farish have worked really hard to do a whole series of computer models looking at the potential coupling between the magnetic fields of these stars and these close-in planets. If you have a really small, faint, cool star like a red dwarf, in order to be a world that's capable of having liquid water on your surface, you have to be really close in. It turns out if you get too close, the magnetic field of that star will couple with your planet. And in looking at all the regular worlds that we refer to as exciting and habitable, so here we're looking at the TRAPPIST-1 systems, in looking at all of these systems, Ross 128, Proxima Centauri, turns out all these dwarf stars are magnetically, potentially stripping the atmospheres from these planets. Essentially what happens is when you couple the magnetic field of the planet with the star, you have a flow of materials. And in this case, that material that's flowing is the atmosphere of the planet that goes away. And it's really hard to have life if you have no atmosphere. So we have found yet one more reason that these red dwarf worlds probably don't support any life. Now, we understand that, in the words of Jeff Goldblum, life finds a way. But in this case, well, life just has that much harder of a time trying to find a way. But as I said, we're finding planets pretty much everywhere. And it turns out they've got to be pretty common because of some of the bizarro ways that we're finding them. A number of years ago, there was a planet found around a star in the constellation Cassiopeia that happened to have a planet next to a star that was gravitationally lensed. So what happened was there's two stars. There's the one closest to the observers, the one further away. And as this closer one passes in front of the background object, its gravity bends light, increasing the amount of light that we're getting from that background object. And this essentially says, hey, look at me, and draws attention to this alignment. And this alignment, when it's just right between a planet and a background star, can also draw attention to the planet that we otherwise could never see. And it's happened again. Astronomers, particularly amateur astronomers working in Japan, noticed that there was a new, oddity in the sky. In this case, it was Tadisha Kajima of Gunma Prefecture, Japan, and he reported a new object in the constellation Taurus. And when folks followed up on this object, it turned out to be a very slowly evolving microlensing event. And in this case, with another one of these small red dwarf stars, a potential Neptune-type object was found at an Earth-like distance from this star. And it turns out this star is close enough that there are hopes that they'll be able to follow up with the multimeter Subaru telescope and actually, confirm an object discovered via gravitational lensing using a telescope. This is the first time we've had this potential to follow up on a planet found through gravitational microlensing. And what was cool is because this was a slowly evolving system, they were actually able to calculate out the mass, the size, all the different physical parameters of both this star and this planet. So we also have really cool models of this system. Now, one of the things that we count on is if we happen to stumble across something, that means that it's probably pretty common. You don't generally stumble across something that's exceedingly rare. You find it through systematic search. It's that four-leaf clover problem where you're probably only going to find a four-leaf clover if you look at a lot of clover. Well, in this instance, it's thought if we can stumble across a Neptune-like object orbiting a red dwarf star using gravitational lensing to find it, this is probably a super common kind of configuration, and this changes how we look at, the kinds of planets that exist around red dwarf stars, which again, probably aren't habitable for life. Now, we have one more story for the day, and this is a case of galaxies in the process of merging, triggering massive amounts of star formation that in turn reshaped a galaxy. And here what we're looking at is the video of a rotation of maps made of this object's gas distribution. And the colors indicate whether the gas is moving toward us or away from us. And what we're finding is, the stars are literally blowing a hole out through the intergalactic media and making it such that we see a strangely distorted gas profile. Okay, something just triggered all sorts of music. Oh, Venmo. Sorry about that. Okay. That was creepy. Um, thank you so much. Um, so it turns out that if your star formation is violent enough, all of the energy of that star formation can push against the gas and dust that makes up the outer layers of a galaxy, blast through it, and essentially create a star formation driven, not really a jet, it's not focused like a jet, but outburst through a galaxy. And that's kind of cool. So, um, I was asked to keep this brief so that we can flip on over to the, um, oh, yes, based lemur. This is something we're observing right now. Okay, so I'm going to flip on over to Annie. So I will see you all after you've had a fabulous morning, evening, and afternoon on the other side, and come by Astronomy Cast later today. Bye-bye.